I am Dr. Srinivasan from Chemistry Department, IARE. Today we will see in this video engineering materials, thermoplastics and thermosetting resins. So thermoplast and thermosetting resins we have seen in the last video as a classification of polymers under the category of forces, intermolecular forces. Okay. So based on the intermolecular forces, thermoplastics and thermosetting resins we have seen. So today we will see more about this further things. In last video we have seen about classifications based on different categories, nature of the monomer, okay, based on intermolecular forces, based on polymerization, like that we have seen. Now we will continue seeing thermoplast and thermosetting resins in this engineering materials topic. So in the last class we have seen based on origin, natural polymers, semi-synthetic, synthetic polymers, okay, and their examples. Linear, based on structure, linear, branched, cross-link, and based on molecular forces, intermolecular elastomers, fibers, thermoplastics, thermosetting polymers or thermosetting resins. Okay. Based on polymerization, main existing mechanism, addition polymers, condensation polymers. Okay. So this is how we have seen the classifications of polymers based on these categories in the last class. Next. Okay, we have seen addition polymerization. We have seen addition polymerization. Polymers formed by this polymerization is called addition polymers. Example: polyethylene, polyvinyl chloride, polystyrene, okay, polyacrylonitrile, etc. These are all addition polymers, or you can also say chain growth polymerization, where the chain will grow when the polymer is formed. As the polymer forms, the chain grows. Addition polymerization is also called chain growth polymerization or chain polymerization. Normally, this addition polymerization happens by free radical mechanism. Okay. So one such free radical mechanism is what we are going to just see here. Generally, any free radical mechanism has three steps. Okay. First, initiation, chain initiation, next propagation, and then next chain initiation step, first step. Second step, chain propagation. Third step, chain termination. Okay. Chain propagation, initiation, propagation, termination. Okay. So first, this is chain initiation step. First, initiation of a radical. Normally, a peroxide is used to create a radical. Benzoyl peroxide or any peroxide. So here benzoyl peroxide, R is for benzene ring. So here also, so we will get initial. This is a free radical. Free radical means it has unpaired electron, odd electron. Normally they are all highly reactive. Free radicals are highly reactive. So as long as free radical is there in the reaction mixture, the reaction will keep propagating. The reaction chain will keep growing. Okay, in this reaction mechanism. So this is a radical. This is a free radical. Now this radical reacts with a monomer. For example, this is monomer. This is free radical, and it will create another new radical. Okay. So by this, so two bonds are considered as two dots like this. So one dot will form here, another dot will go here. So this is how the mechanism. And normally any organic reactions we will show by a arrow, whereas free radicals we will show by single hook arrow. Okay, this is for free radicals. This is for any normal electron pair. So this is how we show the mechanism in organic chemistry of fish hook arrow. It's for free radicals. Okay, that's how it is shown off arrow. Okay, this is the chain initiation. Another new radical has formed. Now this new radical reacts with another monomer and forms another new radical, and then this new radical forms another, reacts with another monomer to form another. Which each, see now, one here, two here, three. So like that, the chain is keep on propagating. So the chain propagation happens unless a change happen till the availability of free radicals. So it will stop only when the free radical formation is stopped, or free radical is fully consumed, or free radical is combined to form a normal molecule. One of that is called chain termination step. There are 4 different ways for chain termination. Okay, normally we will see one of this, which is more common. Both free radical combined to form a bond. Okay, so like this. So these 2 free radicals combine to form a long chain like this. So this is how the addition polymerization occurs by this free radical mechanism. Okay. Addition polymerization occurs by free radical mechanism. These are all common steps. First step, chain. Second step, chain propagation. Third step, chain termination. Okay, fine. Next. Okay, we have seen addition, condensation, polymerization, different examples, all those things. Now we will see the difference between addition and condensation, polymerization. So we know that addition polymerization is also called chain growth. Condensation polymerization is also called step growth. Addition polymerization takes place only in monomers having multiple bonds. Yesterday we have seen in the example, like CH2 double bond, CH, Cl. This is vinylic double bond, vinyl chloride. Okay. Polymerization occurs to give polyvinyl chloride. Okay, PVC, polyvinyl chloride. Like that, we have seen several examples: polyacrylonitrile, polyethylene, polystyrene, like that. So wherever we see, we have a vinylic double bond. Okay, so the presence of double bond unsaturation is required for this addition polymerization or chain growth polymerization reactions. takes place only in monomers having multiple bonds. It takes place in monomers having reactive functional groups. Okay, reactive functional groups. It takes place without any elimination of simple molecules or like ammonia, HCl, water. No other byproduct is formed. Okay. Here it takes place with elimination of small molecules like water, ammonia, methanol, HCl, etc. Okay. Repeat units and monomers are more or less same. Only but double bonds are different. For example, here this both are same. Only the double bond is the difference. Okay. Of course, this chain is there. Here we are not showing chain here. N times of vinyl chloride forming this polymer. But still, there is no addition or removal of any atoms. Okay, only bonds, double bonds are rearranged into double to single bond like that. Repeat units, double bonds have unsaturation has become saturation. Double bonds have become single bond here. Sometimes, if there are two double bonds, then it will reduce to one double bond like that. Repeat units and monomers are different here. Okay. Yesterday we have seen the example of nylon 6,6, okay, where we have COOH in adipic acid functional group, NH2 in hexamethylene diamine, but in the nylon 6,6 there is a new functional group of amide. So these are all comes into the category of polyamides. So this is the polymer. Repeat units and monomers are different. Okay. Reaction is fast and polymer is formed at once in addition. Polymer is formed in gradual step because it's also called step growth. This is chain polymerization. This is step polymerization. Chain growth, step growth, polymerization. So it grew in gradual steps, formed in gradual steps. Number of monomer units decreases steadily throughout the reaction in addition, polymerization. Number of monomer units decreases steadily throughout the reaction. Here, monomers disappear at the early stage of the reaction in addition polymer and condensation polymerization. Molecular weight of the polymer is an integral multiple of molecular weight of monomer in addition polymerization. Whereas here, molecular weight of the polymer need not be an integral multiple of molecular weight of the monomer with respect to condensation polymerization. Okay. So this is how we have seen the differences between these two main polymerizations, addition and condensation. There are a few more which we will. Product obtained are thermoplastics. Product obtained may be thermosetting or thermoplastic. Okay. But addition polymerization majorly gives thermoplastic. Example, polyethylene, polyvinyl chloride, polystyrene. Condensation, bakelite. Bakelite is nothing but urea formaldehyde. Sorry. Bakelite is phenol formaldehyde. Phenol formaldehyde or the monomers for bakelite. Urea formaldehyde resin is also there separately. Urea formaldehyde resin thermoset is also example. Okay. High molecular weight polymer is formed at once in chain growth. Molecular weight of the polymer rises steadily throughout the reaction in step growth polymerization. Longer reaction times have higher yield but have a little effect on molecular weight in addition polymerization. Whereas in condensation, longer reaction times are essential to obtain high molecular weight. So this is the difference between this two. Okay. When some same kind of monomers joins, okay, the polymer is called homopolymers. We have seen the classification. It is prepared by, okay, here example, nylon 6. We have seen nylon 6,6 example for condensation reaction in the last video. Condensation polymerization reaction. Okay. Now, nylon 6, it is prepared by the self-condensation of omega. This is omega amino caproic acid, which is produced from caprolactam. Nylon 6 is also a important polymer. So we will see how it is done. Okay. So there are other types of nylon, nylon 6, 10. Okay, like that is there available. Now we will see nylon 6, how it is prepared. One, 2, 3, 4, 5. Okay. This is caprolactam. Okay. This on heating undergo self-condensation reaction to form NH2 CH2 5 times COOH. This is called omega amino caproic acid. Caproic acid. Okay. This on polymerization gives nylon 6. What is nylon 6? NH CH2 5 times C double bond O n times. This is nylon 6. Okay. Okay. So it's an important polymer. So we have shown this under this condensation, polymerization example. Okay. Self-condensation. Okay. Okay. Next. So in the manufacture of plastics, raw materials like coal, petroleum, cellulose, salt, sulfur, limestone, air, water, etc. are used in the manufacture of plastics. So what is the use of plastics? Advantages of plastic over other engineering materials. Advantages of plastics over other engineering materials. It's a low fabrication cost, low thermal electrical conductivity, high resistance to chemicals and corrosion. That means chemicals and solvents. Plastics reduce noise and vibrations in machines. It is a bad conductor of heat and is useful for making handles, used for hot objects. Most plastics are inflammable. And plastics are electrical insulators and they find large scale use in the electrical industry. PVC piping and all we have seen. We will see the more of about PVC in the later videos. At present, plastics are resistant to chemicals and corrosion. Plastics are clear and transparent, so they can be given beautiful aesthetic colors. Aesthetic appearance will be very good with beautiful colors. Next, plastics. Plastics are nothing but polymers. The word plastics derived from Greek, in which plastic means moldable. Okay. Plastics are high molecular weight organic materials that can be molded into any desired shape by the application of heat and pressure in the presence of catalyst. So plastics means we mean polymers only. Okay. So it's a Greek meaning of word mold. Plastic means moldable. Okay. So all thermoplastics are plastics. Okay. Polyethylene, polystyrene, nylon, polyesters. These are all thermoplastics. They are also called plastics. Next, resin. Resin is a basic building material which are present as essential ingredients in polymers. However, resins can be molded as such into polymer themselves. They belong to the class of thermosettings as per the classification on the basis of intermolecular forces. So we have seen intermolecular forces, thermoplastic and thermosetting plastic. We have also seen that thermoplastic can be softened on heating and it regains its same position same shape when you cool it. Okay, and it is all physical changes, so it is recyclable and moldable again and again, all those things. Whereas thermosetting plastic is when you heat it, it won't get softened, it gets stiffened due to reaction, and then you cannot bring it back to the original shape, and this is due to chemical, so it is chemical changes, and so it is irreversible. That's why it is called thermosetting plastics. Okay, so thermoplastics are mostly linear chain polymers. Linear chain polymers. Here, this is 3D network polymers. We can call it as thermosets. Okay. So we have seen in the last video that under the heading of classification, intermolecular forces, thermoplast, thermosetting. Okay. So we will see more about this two types of plastics. So based on the structure and type of resin used for the manufacture of plastics, they are classified into two main types. One is thermoplastics and second is thermosetting or thermosetting plastics or thermosetting resins or thermosets. Okay. So, what is the difference between these two? Thermoplastic resins or polymers. Thermosetting resins. So, first, thermoplastics are produced by addition polymerization. Thermosetting by condensation, produced by condensation polymerization, which we have seen in the last video, and also how the addition polymerization undergoes free radical mechanism also we have seen now. The resins are made of long chains attached by weak van der Waals forces of attraction. The resins have three-dimensional network structure connected bonds. Okay, in condensation or in thermosetting resins. On heating they soften, and on cooling it becomes stiff. Chemical nature won't change. Okay, it's only a physical change. So physical changes are reversible. So thermoplasts are reversible and they can be moldable. Reversible means they can be molded again and again. On heating they become stiff and hard. No change on cooling. Chemical nature changes. Okay, in thermosets. Thermoplast can be remolded. Thermosets cannot be remolded because one set means they are permanently set. That's why they are called thermoset. Scrap. This is regarding recyclable. Okay. Recycling. Scrap waste products can be used for recycling. Here, thermosetting scraps cannot be used because it cannot be moldable or recyclable. Resins are soft. Resins are soft, weak and less brittle. Whereas thermosetting resins are usually hard, strong and tough and more luster, more brittle. Thermoplasts are soft, weak and less brittle. resins, thermoset resins are hard, strong, tough, and more brittle. And also, thermoplastics are easily soluble in organic solvents. Okay, like for example, PVC, polyethylene. Resins, thermosetting resins are not soluble in organic solvents. Contain long chain polymer with no cross linkage in thermoplastics. And whereas we know thermosetting resins have cross-linked 3D network structure. Okay. So with this, we will finish this video, and we will continue seeing this engineering materials polymers in the next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.